All right, I'm going to begin with the introductions. Thanks for joining us, everyone. I'm Jessica Philippe, the Member Engagement Librarian at South Central Regional Library Council. Today's program is the first in a series that we're calling Moon Mondays. Get ready for the 2024 total solar eclipse. This series is supported in part by the American Astronomical Society's J.M. Pasachoff Solar Eclipse Mini Grants Program. And just a few technical notes before we begin. We are using Zoom meeting today, so while you have access to mics and cameras, we'll ask that you keep those off during the presentation, and then you're welcome to use them after the presentation during the Q&A. And you can also post questions to the chat. And we're recording the talk today, and we'll send a link to that when it's posted to our YouTube channel. So today we're here to learn about the wonder, beauty, and science of eclipses, and we have with us Zoe Lerner-Ponterio. Zoe is the manager of the Spacecraft Planetary Image Facility at Cornell University. So welcome, Zoe.
Thank you so much for having me. Well, I'm so glad that I was invited to give this talk and looking forward to answering a lot of your questions about eclipses. And I would like to begin by reading Cornell's land acknowledgement. Cornell University is located on the traditional homelands of the Gayakono. The Gayakono are members of the Haudenosaunee Confederacy, an alliance of 6 sovereign nations with a historic and contemporary presence on this land. The Confederacy precedes the establishment of Cornell University, New York State, and the United States of America. We acknowledge the painful history of Gayakono dispossession and honor the ongoing connection of the Gayakono people, past and present, to these lands and waters. So I put together this talk a few years ago, actually in response to a request for a lunar eclipse event. And needless to say, it has been enormously popular over the last several months. I know we are all getting very excited for April 8th to come around. I'm certainly looking forward to it. I will say I've never seen a total solar eclipse, so this will be my first time experiencing one. And we will talk about the basics of eclipses, what causes them, what they are, the different kinds, and we will talk about their occurrences, why they seem either common or rare, depending on what type you're talking about. And we will then talk a lot about how best and safest to experience the April 8th eclipse happening here over central New York. So before we begin, we need to talk about shadows. We need to establish what a shadow is. And I'm going to use, because that's what eclipses are, they're shadows. I'm going to use a diagram of a lunar eclipse simply because it's easy to illustrate the concept of the different parts of a shadow. So I want you to imagine that you are in a spacecraft hanging out here at this dot. Now, if I look in this direction toward the sun, I have direct line of sight. I can see the sun. If I look in this direction, I can just see past the Earth and still see the sun. But if I turn my gaze any farther, it will be blocked by the Earth and I will not be able to see part of the sun. So part of the sun is being blocked by the Earth, part of it is not. This is a part of the shadow we call the penumbra. And then if I'm floating, though, in space here, no matter which direction I look in to try and see the sun, my view is completely blocked by the Earth. This is called the umbra. So that is a word that comes from Latin. That's the word for shadow. So an umbra is essentially full shadow, whereas a penumbra is partial shadow. So it really depends on which one you're in as to what type of eclipse you are getting. So there's the lineup for a lunar eclipse. And if we have time at the end, we can talk a bit about lunar eclipses a bit. But lunar and solar eclipses, though they're both eclipses and are similar in that regard, they are vastly different because of perspective, because we are on one of these 3 bodies watching all of this happen. And that means changing perspective changes the experience quite a bit. In a lunar eclipse, it is the moon that is passing into the Earth's shadow. But for a solar eclipse, it is the Earth that's in the moon's shadow. And we can see one of the basic differences here, and that's that the Earth is larger than the moon and therefore casts a larger shadow. The moon casts a very small shadow upon the Earth. So there, the central dark area, that's your umbra, And then the lighter shaded area is the penumbra. So also notice that an umbra decreases with size as you travel away. So let's look at this in another diagram. Obviously not totally to scale, but the moon sitting here, again, that penumbra, that area where if I look in either direction toward the sun, the moon is blocking my view. If I am standing in that umbra, I am being treated to a total solar eclipse. If I am standing in the penumbra, I am being treated to a partial lunar eclipse. So it is the casting of that small shadow by the moon onto the Earth. We actually do have footage of this happening from space, and it's taken by a spacecraft that is in space, holding steady at 1,000,000 miles away from the Earth on the sun's side. So it is always looking at the entire daytime side of the Earth. And here is what it saw with the 2017 total solar eclipse. I want you to watch carefully. That eclipse went across the continental United States, which is right here. There's Florida, there's Mexico. And so we're going to be watching the eclipse happen over the continental United States. There it goes. So that dark spot is the shadow of the moon passing over the Earth. We see that the eclipses always move west to east and crosses across the continental United States. All right, if you happen to be treated to such a site, this is one of many beautiful images taken of a total solar eclipse. So what is blocked versus what is seen? What is blocked is what we call the surface of the sun. And you might be thinking, wait, the sun's not a solid object. It's a ball of gas, or more correctly, plasma. So how can it possibly have a surface? We do define a surface of the sun as essentially the place where all the sunlight comes from. Now, the sun is creating energy in its core through nuclear fusion, and that energy is then traveling from the core outward throughout the sun. And it takes thousands of years for that light to bounce around inside the incredibly dense sun until it randomly follows a path that leads it to the edge of the sun, where suddenly the density goes down enough that the light can escape the sun. And that happens at a very specific place, and that is what we define as the surface of the sun. So essentially, all the sunlight that we are seeing right now is coming from that point on the sun, is when the light finally can stop bouncing around inside the sun and leave the sun. So that's called the photosphere, and that is completely blocked in this image. We do see some solar eruptions, prominences, coming off of the sun and just making their way so that they can be seen. They are coming off the surface. And then we see that wispy, feathery crown, the corona. That's where the word comes from. That is the atmosphere of the sun. And that is much hotter than the surface, but it is also very diffuse. So even though it's 1,000,000 degrees, we actually have a spacecraft called the Parker Solar Probe that flies through the corona, even though it's 1,000,000 degrees. And it's just because there's so little stuff to fly through, there's not a lot there to heat you up. Now, one interesting historical fact about eclipses is these are very old as far as how long we've known about them, centuries, perhaps even millennia. We have understood what eclipses were and known how to predict them. But a very modern eclipse usage came when Einstein proposed his general theory of relativity, the idea that gravity of a massive object would actually bend and warp the fabric of space-time itself. And this was a bold claim, but they came up with a clever way to test it with a solar eclipse that was coming up. During this totality, they very carefully scanned right around the edge there of the moon blocking it to look for stars. And they saw stars that they should not have been able to see. They saw stars that should have been behind the sun, but instead they were seeing them as just right next to the sun. And that was the sun's gravity bending the light like a magnifying glass and making those stars appear to be where they actually weren't. So the starlight was being bent around the sun. And that was one of the first very concrete, anybody could make this measurement, support of Einstein's theories. So that is a total solar eclipse, but there are other types of eclipses. And we have this set up, we review here, but the moon is not always the same distance from the Earth. Its orbit is slightly oval. It's an ellipse, so not a perfect circle. And we can do a very simple experiment, and I will often do this with kids, but adults as well, where I ask everyone to hold up at arm's length one hand with a thumb and another hand with your fist. And then close one eye and start to move your thumb closer to that eye until your thumb grows big enough to cover your whole fist. So your thumb is smaller than your fist, but if you put the thumb closer, it can cover the whole thing because closer things appear bigger. And it's just by a strange little coincidental quirk that we happen to be alive right now at a time where the moon is 400 times closer to us than the sun and 400 times smaller than the sun. And those two cancel out to where they look about the same size in our sky. And that is why you can get the moon to just barely cover the sun. But sometimes the moon is a little farther in its orbit than other times. And if that happens, you get a different kind of eclipse entirely. So exaggerated here, but if we move the moon farther away, we see what happens to the umbra here is it shrinks down to nothing, creating a totally different region that's called the antumbra. So if you're at sea, you are still being treated to a partial, but if you're in that antumbra, you are treated to what's called an annular eclipse. So again, with your fist and your thumb, you've got your thumb covering your whole fist, but if you then move your thumb a little further away, you can get it to the point where it's covering most of your fist, but not quite all of it. And that's what happens in an annular. The moon is just ever so slightly smaller in the sky because it's a little farther away, and it's not quite big enough to cover the whole sun. And here are some beautiful pictures by professional photographers of these annular eclipses. And here it is at full annularity, known as the Ring of Fire. Now, I did do my first eclipse chase just last October to go down and see an annular eclipse that passed over part of the United States. I went down to Texas and drove out to quite the middle of not much Western Texas to catch one of these. I am not a professional photographer, but I went ahead and tried my hand. And here are my photographs of that annular eclipse. So you can see that this indeed is absolutely spectacular. It was very odd. It was noticeably darker, but of course not completely dark. And one thing you might be asking yourself is, okay, you said right now we're at a time we're lucky enough to be at this moon is at this special distance. And that's because we won't always have that. The moon is drifting away from the Earth. When the moon formed, it was much closer to the Earth and Earth's days were much shorter. The moon has been drifting out away from the Earth, slowing Earth's days down ever since. Now, this is happening very slowly nowadays, about the width of your thumb every year, but it is moving away. And you can actually do the calculation to ask yourself, at what point will the moon be too far away to ever be big enough to cause a total solar eclipse? Because as it drifts, it's going to get slightly smaller in our sky. And it turns out we have no need to worry. It's going to be causing total solar eclipses for probably the next 563 million years. But yes, at some point in Earth's future, total solar eclipses will no longer happen. All of them will be annular. Now, another question that might come up at this point, looking at this diagram, is if the moon is going around the Earth, why does this not happen every single month? Why do we not have a lunar eclipse every month and a solar eclipse every month? Shouldn't we get a lunar eclipse every full moon and a solar eclipse every new moon? And the answer is no, we don't, because the moon's orbit is tilted a little bit with respect to Earth's orbit around the sun by 11 degrees. Nothing out in space is perfect circles and perfectly aligned. It's one of the reasons why these alignments are so special. we see that when you are tilted, you can get those umbras just miss each other. The moon's umbra just doesn't, it passes by the Earth either above or below, and the Earth's shadow misses the moon. However, twice a year, as you come around either here or it'll happen again over on this side. So twice a year, you can get this alignment. These are called the nodes, the places where those two ovals intersect, when the two orbits intersect. So twice a year, you do get this alignment. So not twice a month, twice a year. And so one of the questions that might be raised is, hold on, if you're saying we get eclipses twice a year, I mean, they seem so rare. Okay, it's not that they're rare. Again, it's your perspective. So let's talk about lunar eclipses for a second. And for some reason, my mind is just noticing that it's misspelled on that slide as lunal eclipse. Have to fix that. Lunar eclipses, the Earth's shadow is bigger than the moon's shadow. And therefore, it's really easy, as you can see here, for the whole moon to just go completely inside of Earth's umbra. And because we're the ones on Earth, everyone that's on that half of the Earth, nighttime, and who has clear skies, gets to see a lunar eclipse. So you have probably seen one or more lunar eclipses. And if you haven't, don't worry. They are fairly common in that twice a year, there's a chance sometimes you're like, I won't be on the right side of the Earth for this one. But it is not hard to catch one of these. I have seen probably 6 or 7 lunar eclipses in my lifetime without even really trying very hard. So that is why it seems like they're more common. Solar eclipses happen just as often, but look carefully at that diagram. The moon's shadow is tiny compared to the Earth. It's not everyone on Earth on that side who gets to see it. Only the people right in that tiny little circle get to see the eclipse. So it's not that it happens rarely, it's that it's not everyone that gets to see it. So if we look at a map that shows eclipse paths, and this is actually all total and annular solar eclipse paths for 2021 through 2040, so 20 years of eclipses. And if you were to count them all up, yep, there's about 2 per year. But as we see, the paths cover teeny tiny portions of the Earth's surface. And as the Earth's surface goes, there's only a few places where there's lots of humans. You see that a lot of this will pass over open ocean or the Arctic or Antarctic, or over large areas like northern Canada and Siberia that are sparsely populated. And so unless people actually make an effort to go to those places, not many people are going to see that particular eclipse. So looking here at this diagram, this was the one that happened last October, the annular. So Texas is getting treated to 2. I was right about here. And then the blue here, this is April 8th. This is us coming up. There's New York right there. Now I said 2 a year. Where's the other one for next year? It's right here. October this year, there will be one that starts out in the mid-Pacific and travels down and crosses over the very southern tip of South America. So yes, there is a second solar eclipse this year, but not many people are probably going to see that one. So this is why it's a rare occurrence and such an amazing opportunity to see a solar eclipse. To emphasize how much you really want to enjoy the April eclipse, the next total solar eclipse that will cross the lower 48 of the United States will not be until 2045, August 12th, 2045. The next total solar eclipse to be viewable from somewhere in New York State won't be until May 1st of 2079. The next annular eclipse to cross the lower 48 will be in 2046, and the next annular to be visible from New York State will be July 23rd, 2093. So yeah, it's rare because the paths are so small. Now, another question that comes up when looking at this map is, why are the paths all wavy, and some are skinny and some are wide. There's a few reasons for that. One, this is a flat map, and if we all think back to basic geography, and hopefully remember that Earth's surface is curved and that there is no way to take a curved surface and flatten it out into a flat map without distorting things. And this is shown, in fact, in your classic Mercator projection, where, of course, things near the poles get made really big, right? Greenland is not anywhere near that big. And so the paths that are closer to the poles look bigger because of the mapped distortion. They are not actually larger. And the ones closer to the equator look smaller. Now, the size does vary depending on how far away the moon is from the Earth, but most of what you're seeing there is mapped distortion. The waviness comes from the fact that even though the moon's shadow is moving in a straight line as the moon crosses between us and the sun, the Earth's surface is curved and spinning. So if you watch this next video, if you watch carefully, this is April eclipse, that black dot pretty much moves in a straight line. And yet, because it is striking the curved Earth surface, the curved spinning surface of the Earth, it traces a wavy line across the surface as it moves in a straight line in space. So that is why eclipse paths look the way they do. All right, so let's talk about it. Let's talk about this eclipse. Here's the nice New York State map showing you where you can see this. The blue lines mark the boundaries of totality. So if you're between these blue lines, you will see the total eclipse. If you are outside, you will see a partial eclipse. You will not get to the point where the whole sun is blocked. Ithaca, I think, is getting to a 98% blocked. So very close and very much a, if you possibly can, just drive north, because it's really worth it to get from 98% to 100%. The red line is the midline. And what that tells you is that's the point where the totality is going to last the longest, because that's the point at which the alignment is perfect. And so the more lined up you are, the more time you're going to get of those being perfectly aligned. So anywhere in the blue lines is good to experience it. The motivation for getting closer to the red line is just to enjoy more time in totality. So Syracuse here, just on the inside, will experience a little less than 2 minutes of totality, whereas Buffalo, right on the line, is going to get about 3.5 minutes of totality. So this is not a long event. It goes by really fast. So there is something to be said for trying to get close to that red line, but honestly, anywhere between the blue lines is fine. The timing will depend on your exact location. And as you just heard, it's not a very long event, a few minutes. And so I will give you some times, but ultimately you need to look up the specific time for your location. So Buffalo, the totality begins at 3:18 p.m. and ends at 3:22 p.m. So 3:18 to 3:22 p.m. in Buffalo. If we then follow it up to Watertown, fun fact, the distance between Buffalo and Watertown is almost exactly the width of the moon's shadow at that point. So at the moment it ends in Buffalo at 3:22, it begins in Watertown and ends at 3:26. So between 3 and 3:30 is when you're going to want to be experiencing this event. So a great site that I will send in an email to the organizers to pass on to you is Time and Date. It's a website that has lots of information, weather and eclipses and historical information. And it's very easy to type in your exact location and get precise timings on the eclipse and what to expect to see there. Now, of course, safety is key. You don't ever want to look at the sun, specifically the photosphere, the surface of the sun, with your bare eyes. So eclipse glasses are necessary to view an eclipse. And I'm about to show you a video because it's not just a matter of wearing the glasses. There's a procedure to it to ensure your safety. So we'll watch carefully as she's going to put her glasses on and then look up at the sun. And this is key. She's going to turn away and then take them off. Okay. You don't want to make a mistake of being staring up at it with your glasses and then take the glasses off while you're still staring up toward the sun. So you're likely going to be overwhelmed by this event. It's going to be exciting. So I seriously recommend practicing. Get your eclipse glasses out that day and start practicing. Put on, look up, look down, take off, and just do that a few times so you really get that habit. And you will still, even with the glasses, you will not want to sit there and stare at it for more than, I would say, 30 seconds at a time. It is still that intense. So I recommend just taking quick looks. I wouldn't just throw them on there and then stare at it for, a half an hour straight. Just look up occasionally, check in on it. When you're staring at it, you're not going to most of the time see things changing that quickly. For the most part, it's a slow event until that alignment starts to pick up right there. Okay, glasses. How to know if they're safe. Unfortunately, as we found out with the 2017 eclipse, the market got flooded with fake glasses. And it used to be that we would tell you to look for this number on the back, the ISO number. Fortunately, as you can see, you can easily find what that number is on the internet. And so these fake glasses were just slapping that number on there so that they looked legit, even though they were not. So this is a quote taken directly from the American Astronomical Society's page. If you have glasses that you're not sure if they are the right ones, one key thing is you should not, when you put them on, everything should be completely black except for the sun. They list a few other things that you might be able to slightly see through it, such as a bright halogen or bright LED bulb. The sun reflecting off of a mirror or metal might also appear, but all of those things should be very dim, and you really shouldn't notice anything in your field of view except for the sun itself. If you see anything else, then those are not safe glasses. Another thing to point out is if you have glasses left over from the 2017 eclipse, they do not recommend using those. They actually recommend throwing away solar eclipse glasses after 1 year. Just for the reason of as you keep them and wherever you're keeping them in, there can be things that rub on the coating and slightly degrade it, and that makes them a little less safe. So it is recommended that you get fresh eclipse glasses for this eclipse. And as far as where to buy them, again, I'll send this link along, but the American Astronomical Society has a great page where they list reputable sellers, people that you can buy from and know that you're getting the right product and getting a safe product. Another thing about safety is what if you want to look at it through binoculars or through a telescope? All right, you will need a specialized solar filter for those binoculars or that telescope. Do not just stick your glasses in front of it. Actually get ones that are designed for use with your instrument. A good way to think of this is that as the sunlight comes toward your eyes, you want the first thing it hits to be an eclipse, an eclipse filter, a sun filter. The first thing that sunlight hits. So an example of what not to do is do not put your glasses on and then hold up binoculars or look into the viewfinder of a camera. All right. Those binoculars and that viewfinder are gathering a lot more sunlight than your eyes. Think of the width of the opening on the end of that binocular versus the opening of your pupil. Then that light gets super focused onto your eyes. It is too intense for those solar glasses to handle by that point. And I actually saw a pair of glasses where someone did this, and there's two little holes burned in each of the lenses. Thankfully, the person, they didn't hit their eyes, they burned their cheeks. So they weren't badly injured, but that could have been horrible. That could have been blinded. So please make sure that the first thing the sun hits is a solar filter that is appropriate for the device you're looking at it through. A great way that you can look it up, I didn't put a picture in here, is if you don't have a solar filter, you have a telescope or binoculars, but you don't have a solar filter, there's still a great way to view it, and that's projection. You just set up your telescope facing the sun, get like a big white sheet of paper or a big white sheet of poster board works really well too. Get that at a good distance and adjust the focus, and it literally projects a scene of the sun onto that. You also can do this on the ground by simply like getting a colander or punching a hole in an index card, or even like we were crossing our fingers in the 2017 one to create tiny holes between our fingers. Any tiny hole can be used essentially as a pinhole camera to project an image of the sun. This is why one cool thing to look at when it's close to totality is if there's trees somewhere, and if you're used to like sunlight streaming through the leaves, there probably won't be too many leaves in April, but you can get little eclipses all over the place. Like instead of that dappled circle all over the ground, there are little crescents all over the ground. There's lots of fun ways to enjoy eclipse, even if you do not have glasses or filters. Any small hole held up and looked down at the shadow on the ground can create a pinhole effect and reveal the shape of the sun. Now, the really awesome exception to all this is that once totality hits, you can take off the glasses and look with your naked eyes, or through binoculars, or through a telescope. And this is because the surface of the sun is covered. In fact, if you leave your glasses on, you will see nothing because this is not bright enough to make it through your solar glasses. This is very important, though, therefore, to have in mind how long totality lasts for you, because you do not want to still be staring at this when the alignment ends and the sun comes back out. So either setting a timer, knowing how long your totality will be, and setting a timer the moment it starts, or there are apps on the phone you can get that will like make auditory notices telling you like, hey, in 10 seconds, totality ends, so that you know to stop looking directly at it. So do take those safety precautions to make sure that you can enjoy this spectacular sight of being able to stare up, see stars in the sky, and see the atmosphere of the sun around the moon. And you can enjoy that without any glasses or anything necessary. And so at this point, I do want to pause and take people's questions on solar eclipses. I want to make sure we get all of that in. And if there's time, I can talk a bit about lunar eclipses, but we want to make sure we're ready for April.
Okay, that sounds good. I've seen a couple come through the chat that you've answered, but I don't think you addressed this. What is the hybrid eclipse on the map of upcoming eclipses that you shared?
Okay, so yes, someone noticed the details. Yes, so there is something known as a hybrid eclipse. And again, this is the fact that the moon is either a little bit too small to cover the sun or just big enough to cover the sun. And so sometimes it's annular, sometimes it's total. But there are, every once in a while, an eclipse where the moon is right near that sweet spot, so close to it that the eclipse starts out one way and transitions mid-eclipse to the other one. And so the people at the start of it might get a total, but then the people toward the end of it are only getting an annular, or vice versa. And those are very rare because, you know, the moon really has to be just at that distance. And any one person observing it is not really going to see anything spectacular because it's a gradual shift. So everybody will either see a total or an annular, but what you see will depend on where you are in the path.
Interesting. Thank you. Then I don't know if you know the answer to this, but the Marcellus Free Library asked, do eclipse glasses prevent sneezing when looking at the sun?
Oh, I've heard of this phenomenon that some people sneeze in sunlight. I find this fascinating. The problem is that I don't think we yet have a good explanation for what causes that. So if it's something to do with the eyes, then the answer would be yes. But if it's something to do with it hitting the skin, then the answer would be no. So honestly, let's do a citizen science. If you have people attending your eclipse viewing event, who are those people who sneeze in sunlight? I would love to know if wearing the solar eclipse glasses prevents that, because that could be very useful to figuring out why it happens in the first place.
That library was also asking, what are the apps? And I think I missed where you were referring to apps, but maybe you know what they're talking about.
Right. There's two apps, one that gives you really good just location data, and there's the one that gives out the auditory notifications. I don't have those queued up on my phone. I downloaded them for the October, but I think they've gone off the cloud. So I will include that again in the email I'll send to you afterward to distribute to everyone here with the names of those apps.
Okay.
If you go to your app store and search solar eclipse, a few will come up, and you can just try each one, see which one you like better. You can Google like what do people recommend, but there is one that I know calls out, auditory notifications, and I'll make sure that I look up what that one is called, so that we can have people aware of it.
Neat. Okay. And then Mary Carol was asking regarding using a telescope. I've never used one without a solar filter on the end. Would it be dangerous to aim it at the sun without one?
So it is not dangerous to aim a telescope at the sun without a solar filter. What is dangerous is to put your eye anywhere near the other end of it. But as I said, setting up a big, either like a nice white space like a sidewalk that it's shining on, or a nice big white sheet of paper or board, will actually make a very nice projection. And let me see if I can quickly call up. I should have included a picture of this, but let's see if I can very quickly bring up a picture of what this looks like. All right, I'm gonna change my share. This. Okay. So if you look here at these two images, this one shows you how to set up your telescope so that it helps to have something to kind of block light around it, to keep away the stray light. You point the telescope directly at the sun, and then you have something here, a surface to project it on. And so here's someone who just has a cardboard box here. They've got their telescope pointed at the sun. Their telescope projects at a 90-degree angle. And here you can see the sun near the beginning of a total solar eclipse. So it creates a little image there of the sun. And you can actually do this at any time as a way to see sunspots. So let's see here, more pictures of people doing this. People will just take like a board, whiteboard. There's fancy things you can buy to attach to your telescope, but it's a pretty straightforward thing. I've run out with the telescope really fast. Just kind of point it at the sun, have a piece of paper there, and you can see it. And as I said, it's the sun's near its peak activity, which means there should also be some noticeable sunspots, hopefully going on at the same time. So you will get to see those as well. There's a picture with the sunspots. You can see sunspots there.
And Allison asked, what about taking photos with a camera? Does it need protecting?
So yes, as I said, I tried my hand at taking pictures of the annular one in October. I did use a solar filter that came with my glasses. I ordered from Celestron, and they had a pack that included glasses and a small filter suitable for a camera lens. And I was able to hook that to the end of my camera. Again, you want the first thing sunlight hits to be the filter. And I was able to take those pictures I showed you. Now, it does take quite a bit of fiddling with your settings, like your exposure and your ISO and all of those. I'm not an expert, so I pretty much just played around with it, took about 600 pictures and got like 5 good ones because I had no idea what I was doing, and I was happy to just get those. So it is trickier to take it with a total solar eclipse because, of course, totality suddenly requires you to shift everything. You've got to take that solar filter off. You've got to readjust all your camera settings to be able to capture the totality. And so I would not recommend trying to do that if you are not an experienced photographer, at least not without a great deal of research. In that case, if you really want a picture, I would recommend aiming to try and take a picture of the totality, which means not messing with the solar filter, but having your camera kind of ready to go. You should not have your camera sitting there pointing at the sun for long periods of time without a solar filter on it. It can harm, if it's a digital camera, it can harm the CCD detector. It can harm some of the internal optics. But you can just have your camera kind of ready to go. And then once totality starts, point it up at there, play around with the settings, see if you can get a decent shot of the totality. I might try that, but honestly, I think since I've never seen one, I might just, surrender to the experience and just not try to be fussing with anything in that moment, and just enjoy it with my family. I will say people were trying to use their phones at the one in October, and none of us could get the phone to focus, even using the solar filter. It was just, the sun is too small for something like a phone camera to do, unless it's probably a much nicer phone camera than the one I have. I don't have like the latest, greatest phone camera. So maybe some of the phone cameras that are really good could do it. But for the most part, I wouldn't trust a phone camera to it. I will test out whether or not I can catch the totality on my phone, but I'm not holding out much hope.
And does it need a filter? That was a follow-up question in the chat, the phone.
Yes. So again, if it's not during totality, everything needs a filter with the exception of that telescope projection method. So yes, your phone, please do not point your phone at the sun. It won't probably kill it, but your images might be, impacted from then on. It might damage some of the digital detection devices that are in there. So yes, even if you're gonna try your hand at your at your phone, you need a solar filter. You can use, I tried it with the one that came from my camera. And then, or you can even you can take solar eclipse glasses and try sticking them in front of your phone. That would work too, because your phone's like the size of your eye, so it's good. But as I said, I didn't have a lot of luck with the phone being able to resolve it. But again, during totality, no filters necessary for any device, including your eyes.
So where are you planning to view the eclipse with your family then?
I'm going to be up in Oswego. A few months ago, I think I grabbed one of the last verbos along the lake there. And so we're going to go up for the whole weekend. Because one of the things that I've been told based on the 2017 eclipse is to expect an inundation into the path of totality, which means traffic. So I'm glad you brought this up, because I would not recommend sitting there at like 1 p.m. on Monday and being like, let's drive up to the eclipse if you're not in the path. You might run into traffic even on back roads. There were farms that were inundated with people coming from other places trying to get into the path of totality. For that reason, like I said, I rented the house the whole weekend. We're going to go up on Friday, enjoy a weekend on the lake. Hopefully the weather won't be awful. And then we're there already and we're not fighting traffic. So I'd recommend getting there not the day of, and if you can't travel till the day of, leave in the morning. Give yourself several hours to get yourself where you're going and find a nice spot. It might not be crazy, but expect it to be. I also had someone point out that the worst traffic is typically right after the eclipse, because while people will make their way up leading up to it at varying times, once it's over, everyone suddenly wants to leave and go home. And so do not expect that, come 3:40 in the afternoon, you'll just be able to pack up, get on the road, and be home in your normal amount of time. So allow even more buffer, I would say, on the other side of things. Don't plan to need to be anywhere that afternoon or evening.
Very good points. Thank you. So we do have 15 more minutes, and you did mention you had some information about lunar eclipses. So you are.
I do. We can go ahead with that. Awesome.
The moon was in the news this weekend, I saw, because it's shrinking.
Again, one of those that's probably either they were talking about the fact that it's shrinking in the sky because it's moving away, or that it's actually shrinking because, well, yeah, stuff is getting blasted off of it all the time, but nothing that we need to worry about. Certainly,
it wasn't the moving away; it was
cooling. That's true. Okay, it was the cooling of it. I mean, we definitely see evidence that Mercury has shrunken on its surface, But yes, technically all of the rocky bodies, all the planets actually, as they cool, are going to shrink slightly. So yeah, that'll happen. Nothing to worry about though. All right, so yeah, let's talk about lunar eclipses. So I mentioned the fact that they're quote unquote easier to get because the Earth has a much bigger shadow, and also everyone on that side of the Earth can see the moon go into that shadow. So it's a perspective thing as much as it's a bigger shadow thing. So if you've ever seen one, it has a very distinctive look to it. If you see, these will be listed, and I had someone ask about it the last time I gave this talk. They said, I hear that there's a penumbral eclipse coming up in March, and I really did not, I was like, what are they talking about? It's a penumbral lunar eclipse. If you see that, ignore it. You're not going to be able to really notice anything because this first picture here, that is technically in the eclipse. The moon is in the Earth's penumbra, but the penumbra number is only a partial shadowing. And so the only thing that really happens is things dim a little bit, but you're not going to see any kind of like part of an actual shadow happen. And you probably won't even notice it with your eyes. The way our eyes detect light are such that if you went out during that penumbral eclipse and looked at the full moon, you'd probably not see anything noticeably different about it. So it's technically an eclipse, but not one that our eyes really can detect. What's exciting is when that umbra starts to come in. And notice here that if you trace this, you can notice, yeah, the Earth's shadow is much bigger than the moon. So there's plenty to cover it. And as that shadow moves across the moon, it blocks more and more of the moon. So this is very different than the phases of the moon. And a really interesting thing happens here that as you get close to totality and you really start to block out the part of the moon that sunlight is hitting, which is much brighter than the rest of the moon at this point, totality gives this red color to the moon. It doesn't stay completely black. And this is truly what it'll look like. It will look black up until you get really close to and enter the totality, and suddenly you'll see the red color. The reason you don't see the red color here is because this portion, you can see it here in this picture on the way out, is so bright once the sun is hitting it that it really washes out that darker color. So that reddish color is always there in the umbra. It just doesn't really become visible until you really kind of block out all the parts of the moon that the sun is hitting because it's bright. So this is sometimes called the blood moon. That's all a blood moon is. It's a lunar eclipse, a total lunar eclipse. That's it. So the color, right, where does that come from? Because we didn't see any color like that when we watched the moon shadow go across the Earth. Now, what comes next is an animation, a movie animation, not a real movie. Someone made of the perspective shift of what if you're standing on the moon during a lunar eclipse. And we see here you're on the moon and the sun goes behind the Earth. The Earth blocks the sun. So what we call a lunar eclipse for people on the moon is a solar eclipse. That's what I meant, perspective shift. Suddenly, astronauts someday who live and work on the moon, when we hear there's a lunar eclipse, they're going to get a solar eclipse. But if you notice something really interesting happened there as we enter the totality, was again, things didn't go completely dark. So it looks like it's going to go completely dark here, but then the sunlight shining around. Now, that's not so much the sun's corona at this point, because we're even blocking the corona with the Earth because it's bigger than the sun, because Earth is bigger than the moon. So here's an enhanced view on this next slide of what this might look like to an astronaut standing on the moon. I really hope someday that we have an astronaut take a real photo of this because it will be spectacular. So what you see here is one, you'll be able to see the stars come out because the sun won't be washing those out. You'll see the nighttime side of the Earth. So we see the night lights of the cities of Earth. And now we see the moon bathed in this red color, and we see a different kind of ring of fire, a red ring right around the Earth. And I'm wondering if you want to jump into the chat, if you think you can tell me what that red circle is more. What's causing the red color? Ah, someone got it. Atmosphere. Yes. So the Earth has something that the moon doesn't, which is air. And for the same reason that sunsets and sunrises are shades of red and orange, it's because our sky scatters blue light. That's also the reason our sky is blue. As sunlight goes through our atmosphere, blue light gets scattered more, and that's why that's what you see when you look away from the sun. You see a blue sky. But during sunrise and sunset, when the sun is passing through a lot of air on its way to you, suddenly all the blue light has been scattered away out of that path, and all that it's getting to you is those warmer tones, those reds and oranges. So what we're seeing here is the sun behind the Earth, but instead of blocking all of the sunlight, a little bit of the sunlight is hitting the atmosphere and getting kind of bent and filtered through the atmosphere. And that's what's causing the moon to turn red. And so on the moon, you would get this kind of effect of everything would just be kind of reddish all over the place. This is just a really amazing thing to think about. And like I said, I hope astronauts someday can take an actual photo because I bet it's spectacular. What's also interesting with this is that the color the moon turns is different a little bit with each eclipse. And it's because it depends on what's going on in Earth's atmosphere, especially the places that are right along the terminator here. It can be a different color if, say, there's been a recent volcanic eruption. That can change the color that's getting filtered and can make it either more or less red. I saw a solar eclipse once that was very brown. It was hardly reddish at all. I've seen other ones that are extremely red. So atmospheric conditions can affect what the different lunar eclipses look like. So yeah, you only want to look for when there's either partial or total lunar eclipses. Penumbral ones, you won't really notice anything. But yeah, anyone who's on the nighttime sky side of the Earth in that time who has clear skies will get to see it. So questions on lunar eclipses? I should know when the next one's going to happen too. Oh yeah, it's the point we talked about the nodes, right? It's called eclipse season, the whole twice a year thing. They happen together, which means there's definitely a lunar eclipse that's happening 2 weeks before. That's that penumbral one that person was asking me about because they're in Hawaii. So some people are going to get a total lunar eclipse in late March, pretty much 2 weeks before the solar eclipse. So the eclipses always happen 2 weeks apart, half a month. So if you know there's a solar eclipse, you know there's going to be a lunar one either 2 weeks before or 2 weeks after, almost certainly. And that happens twice a year.
So yeah, you can put questions in the chat, and you can also feel free to put back on your video and jump onto audio if you'd like. And I'm remembering it's a solar eclipse question, but I read somewhere that you might be able to see the solar flares while that's happening. I'm just curious if when you've ever seen a solar eclipse, if you've been able to see that, and would that be like something happening in that crown area?
So yeah, let's bring up that picture. So again, I have never seen one in person. I've only seen pictures of them in video. So in this picture, we do indeed see, if you look at like these reddish blobs here, those are solar prominences. So those are eruptions on the surface that could be, if they're really strong, they're called flares. I think this is something you would need a really good telescope and be really skilled with that telescope or that camera to be able to see these. So I do not think that that's an effect that the everyday person using, pretty normal amateur methods is going to be able to see. This is not a photo that should be taken as what you should expect to see with your eyes or even with a telescope. I think that this is a very skilled person with a very nice telescope and camera who took this picture. Also keep in mind, it depends on exactly how big the moon is. If the moon is too big, it might cover even those. So this person also probably caught an eclipse where the moon was just barely big enough to cover the sun, but still reveal those solar prominences. So Yeah, I picked this one because it's really pretty, but it's also like shouldn't set expectations too high as to being able to see those. Astronomers with good telescopes, professionals will probably be able to catch some of this activity though.
Got it. So are there any other questions for Zoe? Well, I just put a link to a survey into the chat. And I also want to mention that our next Moon Monday program is going to be Monday, February 12th, noon to 1 p.m. And we have a panel of folks from regional observatories and science organizations to talk about their planning around the eclipse and some other programming that they do. I'm just checking the chat.
Awesome. Yes, there will be several people across YouTube live streaming the eclipse, I'm sure. So this brings up an important point. I'm glad someone said this. What if the weather is, well, April in central New York? What if it's cloudy? What if it's raining? Um, it's still worth getting into the path of totality. It's definitely, obviously, not worth doing anything if you're not in totality. But think about it. You know whether it's day or night when it's cloudy and when it's raining. When the totality hits, it will be like nighttime. You will see stars if the skies are clear, which means even if it's cloudy, you will notice it suddenly go dark. You will notice a drop in temperature, I am told. You might notice changes in animals' behavior all of a sudden. So it will still be something to experience, if not with your eyes and actually seeing it as a kind of full body experience. So even if the weather is horrible, I would still recommend getting into the path of totality and just to have the experience of like sitting there and it's just like, I imagine it's like pouring rain and all of a sudden it just goes dark. I think that would still be pretty cool. So
Nice. So I'll be sending out a follow-up email with a link to this recording, as well as links to all of the upcoming programs in this series and information about how to request certificates of attendance for today. And Mary Carol, you have a question?
Yeah, just a quick one. So we don't have Fuertes next week coming to the program, but are there programs that you know of that Cornell will be doing in conjunction with the eclipse?
so I actually have a meeting, I think either this week or next, on that exact topic of what Cornell events they're going to do in conjunction with that. So stay tuned. That is yet to be decided and announced. So that I'm they've asked me what they think that what I think they should do. So we've set up a meeting. So they don't have set plans yet. It's unclear whether they are going to say like have classes pause and everyone can go outside and take a look, have an organized watch party, have actual transportation opportunities. We're not sure, but I certainly will be making an announcement on my email listserv, which if you're not on, you can certainly contact me. And I don't spam out a lot of stuff. I maybe send out something like once a month ish. So if you'd just like to be made aware of stuff like that going on, you can join my list.
That sounds great. And if there's anything that the public could participate in, we'd be glad to pass that along.
Definitely.
Thanks.
Well, thanks so much, Zoe. This was very mind expanding, and thank you to our audience. And we've got a clear sky today in Ithaca, so hopefully people can go out and enjoy the waning crescent moon this evening.
Excellent. Thank you so much for having me.
Thanks. Have a great afternoon, everyone.